Hi, my name is Joshua Oliver, and I am a third year computer science major at WSU Pullman. And I worked under Gwen Hoheisel and Dr. Lovcoat for my project, which was aiding in the detection of spotted wing Drosophila, or fruit fly, larvae in blueberries. The whole necessity for this project stemmed from the fact that you can't sell fruit with fruit fly larvae inside of them. There is a zero tolerance policy for it. Because of that, certain control measures have been integrated to help prevent the spread of this larvae. However, the analysis of how effective each of these control measures are depend on how many larvae are still showing up inside your fruit. This analysis process for blueberries is shown on the bottom right-hand side of this screen, where your blueberries are put through this filtration system, and then the larvae inside of them come out on the bottom in this coffee filter almost piece, where you would then manually count your larvae and classify them accordingly. The point of this project was to develop a mobile app that uses a machine learning model to automatically count and classify your larvae so you don't have to do it by hand. There have been two softwares that I found in the past that have a similar approach. However, these are either region specific, only focus on detecting adult fruit flies, or are far too complex for an average user to be able to pick up, interpret, and use easily. To actually make this app, I followed a 4-step workflow plan. The first step being the preparation part, because I've never actually developed an app before, so I needed to understand what tools I would be using to do that. I landed on a software developer kit called Android Studio, which used a coding language called Dart. Next, I moved on to the design process, which was designing each of the actual look of the different screens of the app. I used a website called Figma to do this because it had really easy to use drag and drop icons and prevented me from actually having to code anything while still being able to see what my app would look like. The next step was the where I spent the majority of my internship on, which was the actual creation of the app, and it followed a process of coding a certain feature or a certain look, fixing any bugs or errors, and then receiving feedback, etc. Finally, the last step would be to deploy the first finished prototype of the app and release any updates when necessary. With that being said, I'd like to introduce the app called Drosophila Detector. On the left-hand side of the screen shows the splash page or boot up page that happens when you first tap on the app before it takes you to this middle screen here, which is the home page. A user has two primary options to upload photos. They can either capture a live image or upload a pre-existing one. And in the upper right-hand side, this information icon shows you the kinds of images we're expecting you to upload. Again, it's a photo of that bottom coffee filtration piece shown earlier. If you hit the browse button, it takes you to your camera gallery. You can select a photo to upload. If you hit the capture button, it will ask for the necessary permissions to use the hardware on your phone before it leads you to this camera display shown on this right-hand side, where the idea is to align that circular coffee filter with this circular template before you take your image. After you upload a photo, the app will load before it displays that same image back to you. However, this time the machine learning model has detected the larvae inside your image and has outlined them in red as shown here. And then the total count of your larvae would appear at the bottom with the different classifications as well. Big and small in this case are just placeholder text. They can be whatever you want them to be, whether that's male or female, etc. If you don't like the image you took, you can hit the retake photo option. If you do like the image, you can hit the save button and this dialog box will appear saying your image has been saved. To actually access your saved images, you click on this previous results tab down at the bottom and it will take you to a page that looks something like this photo on the left-hand side. Each of the images are stored inside a text box where you have, as alongside your photo, you also have a title of your image, the timestamp of when you took the photo, and then the results from the analysis as well. The idea behind this page was to allow users to manually select what photos they like to export, and then the exportation would be a very seamless process to Excel or Google Sheets, where your title of the image would appear along with the date, timestamp, and then the results, all shown by this bottom image on the screen here. Additionally, there are mass exportation options through this menu icon in the upper right-hand corner, where you would be able to export just the photos, just the data surrounding each of the photos, or both. Finally, if you choose to try to access your saved images before you've actually saved any, you'll get a little box saying you can't access it, there are no saved images. Overall, the development of this app will really help make a much more efficient analysis process of different control measures and will henceforth provide faster feedback about how those control measures are doing. In terms of what's next for the application, we still need to fix any remaining bugs that remain, test the precision of different machine learning models to pick the best one, integrate any remaining features, and then finally release the app on Android devices and work on release for iOS devices as well. This whole process and internship has taught me a lot. The three primary objectives that I've learned have been the software development process as a whole, because I've had zero experience with that before. So learning how to do it during this internship has provided incredible insight towards my future career and what I will be doing down the line. Additionally, I've learned more technical skills such as having better code management and organization. And finally, I learned how to communicate, and not just communicate, but professionally communicate, whether that was through attending bi-weekly meetings to receive feedback on how I'm doing with the app, reaching out to people and being proactive about receiving help, etc. With that being said, I'd like to give a very special thanks to my mentors once again, Gwen Hoheisel and Dr. Lavcote. I would also like to thank Srikanth and Datta over at CPAS for helping me with some more of the technical pieces of the application. And finally, I'd like to thank the Agate Institute as a whole for providing me with the opportunity to gain the software development skills and contribute to the ag industry as a whole. So thank you. That was my project.